So with the first analysis we are going to do, we are going to do some simple regression analysis using IBM SPSS Amos. IBM SPSS Amos allows you to do regression, correlation, confirmatory factor analysis, convergent validity analysis, composite reliability analysis, discriminant validity analysis, mediation analysis, moderation analysis, and any other. So one thing about Amos is that it's very modern and it allows you to check for your measurement model to be able to know whether you are actually measuring what you are measuring. So that is the construct validity. So for the purpose of this video, we are going to talk about how to perform simple mediation analysis and also correlation analysis using Amos. And one thing I like about Amos is that it allows you to combine so many analyses. So you can decide to do mediation analysis together with moderation analysis. You can also do, or you can also build a simple regression analysis together with correlation analysis. So the first thing we need to do is to import our data, which we are going to use we are using the sample data set from Amos. So you just click on the first thing, which is labeled as select data file. We are looking for dosage and performance. So you click file name, click on dosage and performance one, then you open the data. So you see they tell you that the number of, so n means the number of observations. That's the sample size, which is 1000. So you click OK. So the first thing doing this, the next thing you should do is to locate where your variables are. So you come to here, which is list variables in dataset, click on it, and you can see the number of variables we have. So we have dosage, performance, group. So you see that we don't have something like ATT1, ATT2, or item 1, item 2. So it means that these are observed variables or manifest variables. So as I said earlier, if you are dealing with manifest observed variables, we use this. So you see draw observed variables. So you click this and draw a shape of your interest. So you can draw a similar one again, or better still, you can delete this and use the duplicate function, duplicate objects. So you click on list variables in dataset. You want to see how dosage influence performance of the drug. So you can click this hold and drop inside here. You can do same for performance, which is the performance of the drug or how effective the drug is. Then you put it here. So we can close this. With this, we call draw path. This allows you to do regression analysis or prediction based on independent variable independent. This for correlation, which we forgot to talk of, draw covariances. Also allows you to co-vary error terms so that you can achieve a good fit or adequate fit. So you click on this. Since we want regression, then we draw, you just highlight, you see it must be red and drag to in which is green. So we want to say that dosage is predicting performance. So we want to see whether it's positive or negative. We can decide to say that let's look for the correlation as well. So in the modern analysis, which is same, it allows us to draw. So I'll just click on this and I draw like this. I think since they are of the same variables, this ignores. So let's say, for instance, we want to do, so let's start with the regression. But since we have a simple model, so this is not allowing us to do that. So we click on this. So since we want standardized estimates, as I said earlier, we click analysis properties. We leave this by default. We look for output. Then you click on standardized estimates. Then you close. So the next thing is to click on calculate estimate. So you click on this. You see, Amos does not have permission to write, so we have to save the data file. So you click save as. Let's say desktop. We have a same model. then you save. So let's say Amos tutorials, then you click save. So you click on this, proceed with analysis. They tell you the variables are endogenous but have no residual variables. So it means that because they are manifest, this is what you see. So you can consider proceed with the analysis. And okay, either the constraint on values are bad. Okay, for example, if you request okay, that prevents covariance, just to make sure that every end has a residual associated with it. So here, since we are doing a prediction, we know that dosage can only explain a portion of performance. That is what we call the R square. So we need to put an error term on this. So you click on this, then this is the error term. So this particular function, add a unique value to an existing, helps you to put an error term on the dependent or endogenous variable. This is the exogenous and this endogenous. So since we don't have this, so now that we have this, we can decide we need to label the error term. So we double click, then you can put something there. Let's say maybe, but let's leave it this way. Let's do it the easiest way. Click on plugin and you can say name unobserved variable. So you see it becomes E1. It's the same. So you can also decide to do it this way. The time we did not have this, you can locate text. If it is this way, just double click on it, come to text, and you can see E1 in small letters. So we can now do our estimation, and we have this. So as I said earlier too, you see this is now active. So we see what we call view text. Click on the output. Then since we are not interested in safe, we might decide to ignore this. So we go to estimates and you can see this. So you see it means that this P with 3 asterisks means that it is less than 0.01. So it means that it's statistically significant. The estimate is 0.824. It means that dosage predicts performance, which is 0.82 estimate. So 1 unit increase in dosage result in 0.82 times 0.824 times increase. So it's like once you increase dosage by 1, the rate at which performance increase is 0.824, or within performance, this is what changes. So since we are interested in standardized, this is unstandardized. It means that we need to use this, which is a standard regression. So when we are reporting, you can report the SE, critical ratio, p value, but with the estimate, you do with this. That's the beta. So these are the variances which is of no interest to us, so we can close this. So let's say we want to do correlation. We don't need any error term. So you just need to delete this since we are not predicting, and delete this. You draw your covariance between the two distances. We see this way. So let's say after drawing this, it's not in good shape. You can just click on this. You see, click on this and it resizes it for you. So you can click here and you perform the analysis. But with this, you do not get anything. So we need to look for the correlation. So you click on analysis properties. So you see implied moments, which is a different thing. But let's use this correlation SMS and implied moments. So you rerun the analysis again. Go to view text, estimates, scalars. You see correlation. So you see the correlation between performance and dosage is 0.214. And you can check the covariance. So if the covariance is statistically significant, it means that the correlation is also significant. So if here is not significant, it means that your correlation is not significant. So that's a correlation between these two. But one advantage of Amos is that you can also check for the normality of these variables. And this can be done by clicking analysis properties again. Look for test for normality and outliers. Rerun the analysis. Go to view text. You are going to see something like assessment of normality, and you can check the mean and maximum for these values. Skewness is also there, ketosis is also there, and multivariate normality. So you can check these ketosis and critical ratio, compare it with literature. It falls within the range for normality or normal distribution, you can cite it and say that your data or your variables were approximately normally distributed.